Good afternoon, good morning, everybody. Thank you for joining us today for today's session on collaborative robots presented by the Australian Cobotics Centre. The Centre works closely with industry partners like Weld Australia to develop the skills and expertise needed to apply and implement collaborative robotic technology. I would now like to hand over to Greg Hearn from the Australian Cobotics Centre.
Hello, everybody. It's great to have so many people here online from around Australia, and I understand some places overseas. So welcome, everybody. We are going to have three sections to this. In a minute, I'll be crossing over to John Roberts, who's the director of the Australian Cobotics Centre, to explain a bit more about cobotics and the applications. He's standing by at the ARM Hub, the Advanced Robotics and Manufacturing Hub.
You can share your home. And for me and the wife, it's been nearly 20 years waiting to get to this.
Yep. And then we're going to go into a bit more explanation about the five programs in the Australian Cobotics Centre. And then finally, we'll finish up with a poll and some Q&A from everybody online. Before we get started, though, I would like us to pause and acknowledge the traditional owners of the lands in Brisbane, where QUT and the AECC is headquartered. And so I'll cross now to Merrin, my colleague, to have the traditional welcome to country.
QUT acknowledges the First Nations owners of the lands on where we gather today and pay our respects to the elders, laws, customs and creation spirits of this country. For thousands of years, the First Nations owners have gathered to share their knowledge and stories. We pay our respects to all Aboriginal and Torres Strait Islander peoples and acknowledge the important role they play within our communities. We recognise their long and continuing connection to country, the lands, winds and waters throughout Australia. We recognise that these lands have always been places of teaching, researching and learning.
Thanks, Merrin, and we'll cross straight to you, John.
Thanks, Greg. So I am today in the Advanced Robotics for Manufacturing Hub, and the ARM Hub is one of the partners of the Centre, the Australian Cobotics Centre. So I'm the director, so welcome to this webinar. I'm going to explain a little bit more about the Centre in a few minutes, but first I wanted to talk about what is a Cobot, because you'll see this very big industrial robot behind me, and you may not think that is a collaborative robot. And of course, most of the time, robots like this are not collaborative robots, but we are trying to develop robotic systems where it's very clear that the human is still at the center of the whatever the action the robot is doing. So I'll show you some welding stuff in a little while, but there are many applications where the thing you want to do is very complicated. It may be that the robot is being used for a different job every day. Therefore, you need a lot of human collaboration to set that robot up. So we'll be turning these large robots also into collaborative robots. That doesn't mean that the people will be in the space in a dangerous location. It just means that the people will be collaborating with the robot. Now, if there's a few bits of noise on the audio, I apologise for that. This facility is actually based at Northgate train station in the north of Brisbane, so it is a little bit noisy. You can see we've got a large prototyping space here, so many of the projects we do, we can do in a very realistic manufacturing way before we actually put them into businesses or industry like yourselves. So what I'm going to do now is just take you, I've got to show you a few examples of the sort of projects that I guess inspired us to start this centre, and you'll get a bit of a sense you will get a bit of a sense of some of the things we're trying to do. Okay, so this is our prototyping space where you will see some things that you probably do recognize as collaborative robots. So these are these relatively small robot arms that are sold as collaborative robots, meaning that they are relatively safe to have people nearby. So we've used this space to sort of test new techniques. In fact, you'll see some Weld Australia provided kit over here. So Weld Australia are one of our partners. You can see their augmented reality systems, which no doubt many of you have used. We won't talk about them in detail now. I just want to show you a couple very quick projects. So this robot here has been used for a thing called incremental sheet forming. So believe it or not, this robot here last week made this piece of metal here. So you see this this cone. This started as a flat sheet. We've then on this robot we put this pick, and all this is it's just a steel rod with kind of a ball on the end, and that's used then to press against the metal and do a thing called incremental sheet forming. So that's one kind of example of where you would use a collaborative robot. I'm now just going to see if I can share my screen and show you a quick time lapse. Let's have a look, see if this has worked. Just bear with me for a sec. Okay, here we go. Hopefully you can see this. So this is a time lapse of incremental sheet forming. So over about, I think this was about an hour, you can see this collaborative robot performing this task. Now, so these sorts of robots and these sorts of techniques can be used to do kind of one-off things, which means that the types of tasks where people are still very much involved. In this particular case, there's someone involved in the programming, of course, and there's somebody tending to this robot and sort of lubricating things. So you'll see, for example, this is the output of what you just saw on that video. So this can be used for all sorts of different things. It could be used for decorative purposes, but probably these sorts of things are going to be used for molds. If you could lay composites in there, you can make composite materials where you have a couple of these sheets and other things in between. But you can start to see how we're using these new types of robots to do different tasks. Now, what I want to do is now show you something that really got us inspired a few years ago now. So you can see this tool here. This is a linisher. So linishers are used by metal workers, you know, up against, say, a metal sheet. You may be linishing. It's backbreaking work. It's a sort of job that the person that would normally do this manually can get a collaborative robot to do. So let me show you this project here. Here we go. Right, so you can see here a time lapse. This is a metal finisher, Matteo, who works actually in the shed next door to the ARM hub here at a company called UAP. He is working here alongside this robot. He actually co-designed this solution with one of the ARM hub's engineers who was working for QUT in a project back then called Design Robotics. She and him co-designed in the space of 3 days this whole system. So they went from concept to this video in 3 days' time. They designed the brackets, they manufactured everything, they decided how to program it, and it took a job that would normally take him 24 hours on the tools down to about 8 hours in total. And of that 8 hours, 6 hours was the robot, with Matteo tending to that robot, and you can see him, changing the sandpaper drums, lubricating the sheet, actually dragging that frame, because they only had 3 days. They didn't motorize that frame, so he kind of dragged it along sideways when it needed to move. So he spent 6 hours of that 8 hours doing that with the robot, and then he would spend 2 hours doing it the old way, fixing up the bits the robot missed. So you notice at the bottom of that video, there's a whole lot of missing spots because, of course, they didn't get it perfect the first time they did this. So it went down from a very difficult job of 24 hours of him on the tools to 2 hours of him on the tools and 6 hours of him working with the robot. And then they replicated that. I think they did 6 sheets for this particular job. So this kind of is one of the prototype projects that showed us the benefits of these robots, and particularly working with the expert in whatever the trade may be. So now, because you're obviously all interested in welding, let me give you another example, which of course is a welding example. So here we go here. Okay, so this is a very similar project to the Linishing project in that this company, Metal Tech Industries, had a problem where they needed to get a collaborative robot to do this welding. Again, in fact, in this case, the same engineer, Amelia, went to the company, helped them integrate this system. This was a 2-day piece of work. Helped get the metal worker there up to speed with the programming, made sure that they understood exactly how to kind of replicate that. And now they're using that in their business. So you can see relatively straightforward using these collaborative robots almost out of the box. You don't need much more special stuff rather than just a little bit of training, not a lot of training, to actually use these in a useful way. So they're now setting up, you can see this table here where while the robot's working on one side, somebody can be working on the other side, setting up the bracketry and that sort of stuff. Okay, I'm going to stop the share there. And Merrin, if you could start the slides again, I'll give a bit of an introduction to the partners of the centre. Okay, so I think you get an idea now what a collaborative robot is in our terms. It's kind of anything where there's people that are sort of at the heart of it. Now, if we could get the next slide, please. Okay, slides are stuck. Do we need to start it again? I feel like one of those IT people. Can you turn it off and on again? Any luck? Merrin, do you know what's happening? Okay. I think
it's coming up on my screen, but it's not on anyone else's.
It is now here, finally.
Good.
Now it says our objectives. Is that what it says on your screen? Okay, all right, great. Okay, and now expertise. Okay, all right, let's stick with expertise. All right. Going quickly to the partners. So we have on the right there, you can see, so I am from QUT. We've also got university partners from UTS and Swinburne. And we've also got the Technical University of Dortmund in Germany. So they're the research side partners. And then part of the centre, we have Weld Australia, hence this webinar, of course. We then have InfraBuild. We've got Cook Medical, who are a medical device company. We've got B&R Enclosures, who make all sorts of enclosures, boxes for all sorts of infrastructure projects. You may even have one at your house. It's very common for an Australian home to have their electricity meter in a B&R Enclosures box. Arm Hub, where I am today, and then IR4, who is a software company that makes smart software for the construction industry, particularly of steel buildings. So we've got a range of industry partners who, who want to cooperate. So one of the sort of the ways we operate in this centre is that the industry partners can share with each other their learnings in the different in their different businesses, and they're not necessarily competing with each other, so they can feel fairly comfortable about sharing things. Okay, if we could get the next slide, please, Merrin. We'll see. Yep, that update. Excellent. So our obvious objectives here, and the federal government is, spending $5 million on us over a 5-year period. Industry's then putting in over another $2 million, and then the university partners are putting in a lot of staff time as well. So that's kind of the investments. This is a serious investment. And we're trying to, of course, to foster opportunities for researchers to work with and understand industry, because Australia is typically fairly bad at that. When you rank Australia in the world and look at all the OECD countries, we're not very good at industry working with universities. So we're trying to improve that. We're trying to improve collaboration generally with Australian higher education sector. And of course, the main thing here is to strengthen the collaborative robotics capabilities of industry and research end users. The uptake, again, in Australia of these types of technologies is not great. It's not terrible, but it's not like in the top half of similar countries. It's kind of in the bottom half. And then, of course, finally, what should come of all of that is to drive growth, productivity, and competitiveness within Australian manufacturing. So that's what we're trying to do. Okay, Mary, can we get the next slide? Now, we've got 5 very diverse research programs, because it's not just about buying a robot and like turning it on and you expect it's going to work in your business. You know, clearly you can buy robots now, but also clearly most companies haven't bought robots and are not using robots. So there's obviously a lot of barriers to that prevent companies adopting collaborative robots where they might make sense. So our 5 research programs are kind of trying to tackle different elements of that problem. And we're going to get somebody from each, one of the co-leaders from each of the research programs will talk a little bit about their program coming next. So I won't steal their thunder now and tell you what they all are. I'll let them speak in a second. But I'm going to do the first one. So Merrin, if you could go to the first slide. Okay, so I'm part of program 1, and this is kind of a research program which is more what you probably would expect from a centre like this, which is it's more about the robotics and the engineering side of the robotics. But it's about taking robotics and collaborative robotics to that next level. So at the moment, you could go, look at this picture here on the left, you could go and buy a robot and you could put a welding torch at the end and you could program it to go from point A to point B. So that's off the shelf stuff now. What we need to get to is a situation where you don't program it to go to point A to point B, but you program it and tell it and instruct it to weld, you know, this particular joint or this particular seam. So, and that may vary depending on where you put it down in front of the robot, or you may not have. It may be a type of product where you've got fairly wide variation in the tolerances, where you know, stuff like this, if you put it in very nice jigs and everything was super precise, it would probably do a great job every time. But the existing technologies won't do that. You need some kind of sensing to figure out, if you've got this high variability, exactly where this kind of torch has got to go. So effectively, we need to make the whole process more intelligent and potentially have a lot more sensing, learn by demonstration, and generally to start to use all the extra manipulation capabilities you get from having a robot, actually use that to the advantage of doing the welding operation. So don't just try and replicate exactly what a human's doing, but then use all this extra, I guess, you know, robots are, you know, they can reach in places people can't. They effectively can jump up on the table. They can do all sorts of things. So we need to use all of that to our advantage. So we're working, of course, with Weld Australia on that, and also our partner Incremental. So many of those projects are working in program 1. So program 1, very kind of what you would expect from a robotics type research centre. So now I will hand over to Jared Donovan, I think, who is going to talk about program 2.
So thanks, John. Program 2 is about human-robot interaction. And so in our program, we're starting to look more at the human side and how you design these robots so they work better with humans in real work places. So we've got 3 sort of research projects that we're working on. The first one's called Human-Robot Interaction Intention Visualization. That's really the idea that we want human operators to be able to see what the robot might be thinking. And this photo here is actually from a commercial product that's available now for forklifts. And it projects like a simple beam of light of where that forklift is going. So we want something similar for robots where if you're working alongside a collaborative robot, you can actually get a sense of what the thing is going to do. And that just, we believe, will help make that human-robot collaboration a lot more efficient. The second one is a human-robot interaction prototyping toolkit. And you can kind of think of this as like the Lego kit for making these new kinds of robot interactions. One of the things about robots is they're complicated, they're sophisticated engineering machines, and we need ways to test out these new ideas that's quite kind of quick and efficient and lightweight to do. So yeah, like a Lego kit of parts, and the idea there is really to make it easier to prototype and test new designs. The sort of thing we might do is actually create a virtual reality simulation of a robot before we test it out in the real world. The last project, multimodal HRI, multimodal human-robot interaction. It's really about more intuitive ways to control robots. So not just using computer coding language and keyboards and mice, but the everyday skills that people might have on the shop floor, being able to gesture to the robot. I'm sure you can imagine some of the gestures people might want to make to the robot sometimes. Being able to talk to the robot or get a sort of haptic feeling of what the robot is doing. So all those 3 we think will help make that work between humans and robots just a little bit easier.
Okay, I think we'll go to program 3 now, and I think that's Glenda Caldwell.
Hello, everyone. Thank you. Yes, so program 3 is about designing socio-technical robotic systems. So there are some overlaps with the other programs. And this one does look at designing the manufacturing systems, the products, and the spaces that will help to connect humans and robots to work together. So the first project is one that focuses really on human factors. And in that project, we'll look at what the knowledge, the interests, the motivation, but also how the human fits within that robot and manufacturing system to better create and develop these systems that address the needs of the people on the workshop floor. The second project is about design factors. So here we look at the needs of the human, but also the needs of the product, the workplace, and the cobot. And again, how do we create an environment? So a spatial environment, but also what are the tools required to make the system work? And also other sort of principles that will need to be implemented to really make the human and the robot work successfully on the workshop floor. The third project is about AR and VR factors. So learning from the human factors and the design factors, we see that the AR, VR sort of virtual space can be used to simulate, to prototype, to evaluate how these systems come together, and to really bring in the human into, exploring how the human and the robot can work together within that manufacturing context. So those are the 3 projects that we'll be working with our industry partners, InfraBuild and B&R Enclosures. So as I said, we overlap a bit with some of the others, but also try to really focus on what the needs of the human is within that manufacturing space on the workshop floor.
Thanks very much, Glenda. And folks, look, if you have any questions, feel free to type them into the chat. Our final session will be a poll where we'll be asking you questions directly just to get an idea of experiences that you've had with robots, what you're currently doing with robots, challenges and opportunities. But if you've got any questions also about the research as we go through, either keep a note to yourself, we'll get back to that, or just put them into the chat. We'll make sure that we circle back there. So now we're going on to program 4, which is quality assurance and compliance. And I think Mickey is speaking to those.
Yeah, thanks, Greg. So program 4 is focused on really on information management. So at one end, we have the high level specification of what is the task or the activities that you want to accomplish with the robot. The reason that you're bringing in cobotics or automation of some sort is some tasks that you need to accomplish, and specifying those as part of your business operations already. But those need to be translated into a sense that the cobotic system can use that, and you can communicate effectively what your intentions are, what your needs are from the cobotic system. So that's about that information translation. And at the other end, we have data that we're collecting, and we need to do something with that data. And the data that the cobotic system is going to collect isn't going to be necessarily the same things that you or I as a human doing a welding operation observe, right? So we may listen to the sound of the welding operation. We may observe the melt pool. The robot can measure some of that as well, but it'll measure them slightly differently. It'll measure the forces differently than we would. It'll measure the sounds differently than we would. And so what we need to be able to do is interpret that through the robotic system into something that is useful for us as humans. And so there's the collection and processing of that at the smaller end. And then in between these two ends, we have that interpretation and translation into human usable forms, whether this is for quality assurance to evaluate your process and how stable it is if you're getting the weld quality that you want, or whatever the activity is, or if it's for automated documentation. So if for things that are critical and need life cycle documentation for regulatory reasons or just your own process improvement, that's where that middle bit comes in. And we split this into 4 projects here about doing that translation, connecting with the digital and the physical twin, doing the automated documentation, and then the analytics to interpret the data that is collected. I think that's program 4. I'll turn it back over to you.
Thanks, Mickey. That's great. So then we have one final program, which is all about the workforce of the future. And I'm going to ask Penny Williams to speak to that.
Thanks, Greg, and hi, everyone. So Greg and I are co-leaders of Program 5, which is the Human Robot Workforce. So this program specifically focuses on the humans. So so for example, I'm from the School of Management, so I'm not a scientist, and what I'm particularly interested in is how the cobots change the workforce and the workplace and the skills that are required in the future. So we have 4 broad projects that we're looking at. The first is about the future workforce, which really looks at it from an industry perspective, or in Weld's case, a Weld member perspective, that considers how cobots might change the skills required for the workforce of the future and what that means for how we train the workforce, and also what it means for job security and the number and types of jobs that we might have in the future. That brings us to the second project, which is about more specifically the job itself. So in a workplace, what does Cobot implementation mean for the design of jobs or redesign of jobs? And how can we identify what are general skills and what might be specialized skills that are changing over time? The third project looks at the workplace itself and how implementation of cobots affects the organisational culture, the change processes, the leadership, and what's required for effective and productive implementation of cobots in a workplace. And then the final project is again more of an industry or sector wide, as well as can be an organisation kind of project that looks at how it changes the composition of the workforce. So do cobots provide us with an opportunity to create a more diverse workforce? And how can cobots allow people to work longer, or people that might be injured to remain at work? And how can all of these changes help the industry to attract more workers in the future?
Thanks very much, Penny, and thanks to all of the leaders from the different programs as well. hopefully that has given everybody an idea of the breadth of the Australian Cobotics Centre. It's not simply about the technology, although that's fundamental to what we do. We're really very interested in how this is going to have a real impact for companies every day, whether that's helping them to be more productive, or whether that's making workplaces safer, or allowing creative new products to be developed. We're really set up to do that with researchers from robotics, engineering, business, as Penny mentioned, but also we have designers and other folks who specialise in human factors and the interaction of people and technology, because we recognise that this is a very complex system. We actually have a question here from David Wilton. And David's question is, he's interested in some of the things we've been talking about, and who should he be talking to about being an industry partner. So David, thanks for that question. Certainly we'd welcome that conversation, and I think John Roberts is the guy to speak with, but at the end of the session we'll make it clear how all the contacting can work to. So thanks for that question, and hopefully we'll get some more as we go through the rest of the half an hour that we've got together, and we're really keen to hear from more people. To help sort of lubricate the conversation, I'm going to hand over to Jared Donovan now, who's going to run a live poll for us about the experiences and challenges that you guys have got. We've got around 55 computers logged in, maybe a couple of people at each site in some cases as well. So plenty of people, different experiences, and we're keen to hear from anyone with a question. So Jared, over to you.
Right, thanks, Greg. So everyone, if you just look into the chat, you'll see that there's a link there that I just pasted. If you open that up, you should see a poll, and we're just asking a couple of really simple questions just to get the conversation started. And the first one is, have you considered buying a robot in your business? So haven't considered it yet, considering it now, bought one but haven't used it, bought one and have it working. So we thought this would be just a nice simple place to sort of start the conversation off. And meanwhile, Greg, I can also see there's another question there from Chris Omerod. I'm from TAFE South Australia, and was wondering if there are any training resources suitable for apprentices.
So hi Chris, and thank you for that question. We have a project that we're working on at the moment with Jobs Queensland, and as part of that we'll be looking at what's actually available to in the TAFE sector. I think it is quite different on a state-by-state basis. Certainly there are resources that will be suitable in each of the different states, and part of what we want to do is actually collect the information so that we can provide a central repository of all the courses that are available. It's something that we're working on at the moment. So thanks for that question, Chris.
Great. Look, I think the voting is slowing down on the poll, so I'm going to start the countdown. It gets very exciting at this point. There's 1 minute left to let us know about what your business is doing in relation to robots. Well, I don't know if others here are surprised by the results. It's actually surprising to me how many have bought a robot already and are already using it. So I would love to hear your success stories, and maybe that could be a good starting point in the Q&A section. What has worked? What are you using robots for so far? And also, I think what's interesting is that one there bought one but haven't used it yet. So you've got this equipment, maybe a matter of time, find out what is actually going on there. Would love to have a conversation about that. So there's about 15 seconds left. Oh, Greg, you've got something to say?
Oh, no, that's okay.
I like this. I like this little activity because it puts a sort of a bit of fun into the thing. Okay, so there's the final results. Let's go to the next one.
Jared, can we just make sure that everyone can see the see the results?
See the results, yeah. What I can do is actually download and share a PDF of the results.
Great.
I'll just share that in the chat after we do the next one.
Great. So I would just also maybe let, on the verbal track, let us know what the most popular answer is on each case. Okay, yeah. So for anyone who can't see it there, 8 people have said they haven't considered buying a robot yet. 6 have said we're considering it now. 1 has said we've bought one but haven't used it. And 6 people have bought one and have it working. So yeah, those are the 4 categories. All right, so the next one, and again, this is just to kind of get the conversation started, but the question here is what would make a robot useful for you? So when you click through to that one, you should see 3 just places where you can type in some answers, but what are the things that would make a robot useful to you? And sorry, is that not showing up on the screen? Okay, thanks for letting me know that, Glenda. Here we go. Sorry about that, everyone. Is that showing now?
We see Greg in your screen.
No.
Okay, try again.
Yep.
Good, all right, that's better. Thanks for letting me know. Zoom newbie mistake there. Okay, so yeah, what would make a robot useful for you? So far we've got training, ease of use, and flexibility. And I'll post that link again in the chat.
It took a minute. I was wondering when the efficiency of the labor savings, but the reason we started developing robots however many years ago was to save people time and effort. I was wondering when that would pop into there.
That comment on Australian site ready is interesting. I wonder what are the sort of specific needs of an Australian site?
Also interesting, I don't see health and safety on here yet.
Mm-hmm.
I like the comment about diversity. That's interesting too. Wonder what people think about that one.
And Mark Potts has put some answers straight into the chat, and that's a good idea too, Mark. Dust, water, IP ratings, load ratings, etc. Good points. All right, I'll start the countdown. Now you can see what I was talking about before. 1 minute until voting closes. Very exciting. And then, Greg, how do you want to, because we've got time for a good Q&A. So, the idea of this was just to give people some thinking, to start those questions flowing. And I can see that there's one from David Wilton already. Shall I hand back over to you? Do you want to leave this up on the screen or
yeah, we can. Yeah, once we get to this one closed, I think we can certainly open it up to questions. And I've got some for the program leaders as well, and we get people to join in. I think that's a really good spectrum of what we're finding every day when we talk to companies about why they're contemplating using cobotics or robots in general.
One of the things that stands out to me is this interesting work one. You know, like we hear this a lot from people when they're talking about robotics is not replacing people, but enhancing the interesting parts of work. So that's really nice to see. All right, I'll stop sharing my screen and give the share back to you, Merrin. And I'll download this as a PDF and share it in the chat for everyone to download if you're interested.
So I might start back with you, John, about the question of how do people get engaged with the centre if they want to, or indeed if they want to become a partner?
So first of all, yeah, email me. so Google my name, Jonathan Roberts, at the centre or QUT, and in the first instance, I'd just love to chat. It'll probably be a three-way chat between Weld Australia, myself, and whoever's getting in contact. But yeah, absolutely, I'm quite happy to do one-on-one Zooms and see if what your needs are. We're talking to a lot of businesses, and they're all very different. Just to see if we can help. Basically, don't want to waste anyone's time. So one-on-one chat with me to start with.
Okay, so we've got another question here from Johan. Case studies where cobots are used and what were the reasons for the implementation? So there we've got quite a few examples, I think, of case studies from the Robotics Centre originally. So who would like to mention a couple that they might have worked with? John, do you want to start on that one?
So, I mean, I can start with that lynching example and motivations for that. I mean, the motivations were twofold in that case. One was to speed up the process because the company had to meet a certain deadline. They thought doing it the traditional way wouldn't meet the deadline, so they invested the time. Even though, of course, it took time to do this new implementation with a cobot, they thought that would save time overall, and in fact it did. But the other motivation, and I think really the very serious motivation, was health and safety, and just having less wear and tear on Matteo, who was actually doing the work. Right, so he was, having to do physio, and it's just a backbreaking job, right? So, so health and safety plus speed and efficiency was the motivation. Also noting that this was in no way meaning he would be no longer required at the business. In fact, he is now kind of the chief robot programmer in that business. He's still on the tools every day. I was over there seeing him this morning. But he also, as well as being on the tools a lot, he also programs the robots. So he's kind of got a more diverse job now. He's happier, he's not hurting his back so much, and everything's going faster. So that's kind of the ideal situation. And another thing I should say is, of course, all of this works a lot better when it's the person that's currently doing the job the traditional way is the one that's involved actually getting it to go the new way. If they're absolutely part of the design of and the implementation of the new way, and they're the one kind of taking care eventually of the new way of doing it, then that it's got a much higher chance of success, right? Of course, because they're an expert in whatever they do now, right? And that's worth a lot, right? So you can't just get in some engineer who doesn't know about the actual task that they're doing to do it. It's very unlikely to succeed. So if you have everybody working together like this, which is why we've also built this very diverse centre, because there's a lot of factors involved here, then it is likely to go much better. So the motivation is speed and safety.
And John, are there other sectors where cobotics have been used, and what might some of the...
Yes. So in other sectors, for example, in traditional automation, cobots are used in a surprising way. Yeah. So, things, imagine...
Because they're really hard to make.
Somebody's, is somebody not on mute? Okay. So one of the uses of cobots is actually in industry, in traditional automation lines where there's pick and place things. Now, traditionally you could have used more non-collaborative robots where you put a cage around everything. But in some of those manufacturing industries where the things that are being picked up are light, you can use collaborative robots now to do that traditional kind of automation pick and place stuff. But you then, because they're collaborative and theoretically safer, you don't need all the guards around them, which means that you can use less floor area because you suddenly don't need these big cages. It also means maintenance is easier because people can kind of go in amongst the robots onto the line. So there has been adoption of collaborative robots in traditional manufacturing because it's literally replacing an old-fashioned, more dangerous robot. So the next step, what we're now seeing, and there's comments about the exponential growth of this in other businesses, is where you've got a lone robot, so not in your mass production kind of line, but a robot where you need to set up that robot maybe every day, because one day it's doing this task, the next day it's doing another task. You know, for a week it might be doing another task, and it's the setting up of those robots doing the new task. You may move it around your factory. That's some of the challenge, how you calibrate those robots or how you design a system so it's tolerant to its being moved around and kind of fiddled with all of the time. So that's where we're going to now. So yeah, they're kind of more movable and mobile.
I see there's another element to the comment that David has made as well in relation to labour shortages and being able to retain welders where people are investing in cobots.
Yes, exactly, and potentially attracting younger people who might not be going into these industries now. If they're going into these industries and their tool set includes a collaborative robot, you know, maybe that's more attractive.
There's a question from Steve about whether we will be working with TAFE and training institutions to equip workers and employees with the skills required in programming cobots. So certainly we've made a start, as I mentioned before, working with Jobs Queensland, which was the Queensland government agencies that looks after TAFE. So we're going through working with Jobs Queensland on doing a review of the kind of skills that are required, whether the current courseware is adequate, whether there are better ways to do training in cobots through short courses or through micro-credentials. So at the moment, we're considering all of those aspects, and certainly in Program 5, that's one of the things that we're going to be working on, Steve, is to get a sense of the skill requirements and also what training and what sort of qualifications are out there. Are they adequate, and what changes do we need to have, not only in terms of the availability of qualifications, but in the kind of mode of training that suits people best? Because certainly the skill aspect and training aspect is very important to us.
Can I just add briefly to that, Greg, and say that those issues are somewhat interrelated too. In that we're hoping that by getting a better handle on the skills that are required and feeding that back into the vet sector, that we can also make these jobs more attractive and more interesting and address some of the skills shortage issues that, you know, in the current environment are unlikely to go away in the short term. So it's a big project, but we understand that implementing a cobot's not it's not the solution in itself. We have to look at all of these things together.
There's another comment from Weld Australia about a module for the new MEM learning resources, and certainly that will be very important to Weld Australia, I imagine. We had a chat with IBSA earlier this week. They're very interested in how we can deal with these issues around training as well. So we've made that connection to the national body, and we want to keep emphasising the importance of not just coming up with the technology, but training and getting the knowledge and skills out there as well. There's a comment from SPO144. I'm not sure what your name is. Sounds a little bit like a robot. but I'm sure you're not. So in my experience, it's essential to have several people capable of operating the Cobot, which I think we would say in terms of the projects we've been doing, that's certainly a real issue. And even in some cases, buying a Cobot and not having anyone is a even more common situation that we've come across as well. So yes, there's no point in having a robot if people in the company don't have the capability to actually operate it, and that might be just operating it, or it might actually be programming it as well. And so yeah, definitely that is a good point. Cool. Okay. Does anyone else have any questions more specifically for any of the program leaders around some of the questions that we have raised there before? Like Jared, you were saying one of the projects in yours is actually about helping people come up with or creating a language or coding tools that will make it easier for people to actually get more use out of the robot. Can you expand a little bit on that, please?
Yeah, that's actually that's one of the really interesting things that we found in our previous project on design robotics, because we were working with this company UAP, who actually manufactures quite large-scale architectural pieces, and they work a lot with architects and designers. One of the really interesting things we found is that there are these architectural software and plugins, like one's called Rhino, and there's a plugin for it called Grasshopper. They have all sorts of crazy names. But once we found out that we could plug those architectural softwares into the robot to get them controlling the robot, that then opened up a whole new range of people to have access to it. And so that incremental sheet forming project that John showed at the start when he did his demo, that actually came out of some of our architectural researcher team members and collaborators from RMIT being able to use their software to control the robot as well. So I think as soon as you make the tools available to people in the language that they already understand, I think you just open the door to all sorts of new uses that we haven't thought of before.
Yeah, I think that's true. And as I recall with UAP, we also had the pattern makers get very excited about that. And there's a question in the chat that perhaps relates to that about the VR and AR and how that integrates, or is imagined that we might integrate that with getting Cobots to work more effectively. So I know some of our research team has got AR and VR in their sites. So who would like to take that one on? Is that another one for you, Jared, or is that maybe? I'm sure
Glenda will also jump in there because she's been thinking about that. So you go for that one, Glenda.
Okay, thank you. It is something that we are very keen and very excited to explore, especially because virtual reality and augmented reality, they provide different ways of humans being immersed in this virtual environment. And whether it's to do training, we've seen, there's a lot of research out there on using VR to train people how to drive, let's say, a tractor or a forklift. And what's great about that is that it's low risk. Right? Because you're in this virtual environment, so you can manage safety issues in this virtual space. So we can see that VR definitely will be an area where we can simulate how the human can control the robot to do the manufacturing task. AR provides another way of engaging with the robot where it's an augmented where you can sort of see a virtual model overlaid onto the physical piece. So our colleagues from UAP, the industry partner we've worked with in the past, they've been really successful at using augmented reality to overlay a virtual model onto the pieces where, especially when it's been quite complex and difficult to translate, a 3D form in 2D documentation. So the augmented reality sort of projects the 3D model over the physical pieces, and then they can position, let's say, a series of rods, and they can mark where the drill holes or the welding has to occur. And we know that it's been successful because they've been able to use that really well, and it's sped up their time. And the people working on the workshop floor have taken to that really, really well. So we can learn from their experience and use that with our industry partners in the center to look at more specific use case scenarios that are more relevant to the, the products that they're creating or the processes that they're using. So there are off-the-shelf, hardware, and there's off-the-shelf software that we can easily start to use and to do the simulation, the prototyping, the evaluation of how some of these human and robot processes need to come together. If necessary, we will look at developing, new software, or that's probably where the sort of new development would go into, is potentially developing a plugin or extending some of the plugins that are available. So Jared mentioned Grasshopper, and we're familiar with a company called Follogram that has a plugin where you can use the AR to do that projection over the physical pieces. So there's also other software that we can access. So we're really excited to work with our industry partners to look at these tools and see how we can maximize them for their benefit.
That's great, Glenda, and I think the AR and VR is something that is useful for training in welding as well. I think, John, in terms of the Weld Australia training device that we've got there, it shows you what the capability of being to overlay a virtual object.
So we're extending that system, which is used for manual training, or extending that to collaborative robot training. Yeah.
Look, we've got one more question and we're coming up to time, so we might leave it at that, but I think it's a great question to finish on, which is how is industry collaboration to be improved? Look, this is really part and parcel of the mission of the Australian Cobotics Centre, is to figure out how to help not only our immediate industry partners, but other people that we bring on board and the broader industry as well, to learn from each other. And we've actually set up an open innovation network, which we can talk to you about, where there will be a broader range of collaboration and learning opportunities, sharing of knowledge, sharing of resources. This is something in the Arm Hub we've been doing now for 3 or 4 years, and we find it a very effective way to have industry partners collaborate with each other and with universities and with other stakeholders as well. Sometimes there are competitive reasons why it's not so easy for people who are competitive with each other in a particular market might find, but we find that often the problem that companies from one sector are having with a company are exactly the same as companies in another sector altogether might be having. And you'll notice that we have building companies, we have medical devices company, we have steel manufacturers, we have a wide range of companies. And we find that often they have a very similar problem and they're not at all in any sense competitors. So that's a great question, and we certainly look forward to collaborating with all the members of Welds more fulsomely as we go forward. We want to really thank you for taking the time to come and join us in this webinar today. We really appreciate that you've given up your time. The program, the session was recorded. If there's any other questions, feel free to reach out to us. If you're interested in collaborating or becoming a partner, please reach out to us, and we would really be very welcoming to have further contact with you. So I think unless there's any other final questions or comments from our research team, we'll wrap it up at that with a big thank you. And thanks very much for your participation, everybody. Thank you to Weld Australia, and thank you to to everyone. And I know there's one thing I've forgotten, and that is that we've got a survey coming. And so Glenda and Penny want to speak about that before you go.
Yeah, I'll just briefly mention, we just did a poll that Jared ran, but we'd like to find out a little bit more detail about the challenges that you're all facing. So before Christmas, in the coming weeks, we will be sending out an online survey. So when you get that invitation, we'd encourage you to click on the link, just answer some of those questions for us, and that will help us tailor our research to the needs of Weld members. So thanks so much, and we look forward to getting your responses to that survey.